Some people may not have noticed it yet, but something radically new is taking shape about 250,000 miles away. While much of humanity still talks about going back to the moon as a symbolic gesture, a nostalgic replay of the Apollo era that likely won't happen before the end of this decade, China is quietly building something far more ambitious than a flag planted in lunar dust. A permanent settlement, a stable presence, an early core of what official documents already call the International Lunar Research Station. This is not a propaganda announcement nor an exercise in futuristic speculation. It is a plan anchored to dates, missions, completed tests, and technologies that are leaving laboratories to face vacuum, extreme cold, radiation, and abrasive lunar dust. Stick with us if you want to see where all this is really going. Yes, that's right. If everything proceeds as planned, by 2035, an operational base will rise near the moon's south pole, and by mid-century, a network of outposts could link that region to the lunar equator and even to the far side of the moon. Said like this, it almost sounds straightforward, but building anything resembling a city where there is no air, where temperatures swing between about plus 250 to minus 275 degrees Fahrenheit, where cosmic radiation strikes unfiltered and electrically charged dust works its way into every mechanism, may well be the most extreme engineering challenge humanity has ever attempted. China's approach is not based on dramatic leaps, but on a carefully orchestrated sequence of robotic missions, each designed to test a critical element and make the next step almost unavoidable. The story truly began in May of 2024, when Chang'e 6 completed a mission that would have sounded like science fiction just a few years earlier, landing on the far side of the moon, collecting samples and bringing them back to Earth. This was not just about setting a technical record. It was about proving the ability to operate in an environment where direct communication with Earth is impossible, and every maneuver must be coordinated through relay satellites. Nearly 4.5 pounds of regolith collected from the South Pole Aitken Basin, the oldest and deepest scar on the lunar surface, represents a scientific treasure nearly 4 billion years old. But above all, they demonstrate that China can manage complex operations in one of the most hostile environments in the solar system. The next step is already underway. Chang'e 7 is heading towards Shackleton Crater near the lunar South Pole, with a complex architecture that includes an orbiter, a lander, a rover, and even a small hopping drone designed to explore permanently shadowed regions, deep pits where sunlight has never reached, and where spectroscopic data suggests scientific deposits of water ice may be hidden. This is where the stakes become truly high, because water is not just something you drink. It means breathable oxygen, hydrogen, and fuel. Enjoy deep, fact-checked space stories? Hit subscribe and activate the notification bell. Otherwise, YouTube will not show you the next videos, and you'll miss what we uncover next. Being able to produce propellant on the moon would effectively turn it into a cosmic gas station, a staging point for missions to Mars without having to lift all that fuel out of Earth's gravity well. Chang'e 7 will map these resources, measure their abundance and distribution, and prepare the ground for Chang'e 8, scheduled for 2028, which will carry a key piece of technology, a 3D printer designed to melt lunar regolith and turn it into bricks and structural components. Meanwhile, about 250 miles above Earth, aboard China's Tiangong space station, tests anticipating that future have already begun. Experimental lunar bricks made from materials that mimic the composition of lunar basalt have been exposed to vacuum, cosmic radiation, micrometeoroid impacts, and extreme thermal cycling. They will remain there for years, periodically returning to Earth for analysis, because before you build a house on the moon, you need to be sure its foundations won't crumble after just a few lunar day-night cycles. The real symbolic leap, however, will come around 2030, when 2 TAIKONAUTS are expected to set foot on the lunar surface. This will not be a short, choreographed visit like those of the Apollo era, but the declared beginning of a sustained human presence. The mission architecture is already public. 2 separate launches from the Wenchang spaceport, one carrying the Lanyu lunar lander, whose name means embracing the moon, and the other carrying the Mengzhu crew capsule, the Dream vessel. Prototype tests are well advanced, emergency procedures have been validated, and the entire system is designed to be reusable and scalable. Not a one-off stunt, but part of a much longer chain. From that point on, the International Lunar Research Station is expected to grow in 2 phases, following a logic that resembles the gradual expansion of a colony more than the construction of a single base. The first phase, targeted for completion by 2035, envisions a core station at the South Pole, autonomous enough to host rotating crews, conduct regular scientific experiments, and begin limited use of local resources. The second phase, looking toward 2045, imagines an extended network capable of linking the South Pole to the lunar equator and even the far side, transforming human presence on the moon into a distributed system of interconnected nodes rather than a lone outpost isolated in the void. At that point, the station would no longer exist only on the moon, but across the lunar surface, lunar orbit, and Earth itself, forming a single 3-dimensional infrastructure through which energy, data, materials, and people move along increasingly routine paths. The infrastructure required to sustain such an ecosystem is ambitious and in many cases unavoidable. Continuous power will be essential in a world where day and night each last about 2 weeks, likely provided by a combination of solar arrays placed on ridges that receive near constant sunlight and compact nuclear reactors. A command and control system will be needed to manage communications, navigation, and safety in near real time, despite the signal delay imposed between Earth and the Moon. On the surface, pressurized rovers will allow astronauts to travel tens of kilometers, dozens of miles between sites without donning spacesuits each time, turning the lunar landscape into something more like a network of connected neighborhoods than a scattering of isolated points. And above all, systems for using local resources must work reliably, extracting water from buried ice, separating oxygen from regolith, melting and printing construction materials, progressively reducing dependence on Earth. All of this unfolds in an environment that offers no mercy. With no atmosphere, the lunar surface is constantly bombarded by cosmic radiation and charged particles from the solar wind, forcing habitats to be buried under several meters, many feet of regolith, or shielded with water ice to keep radiation doses within human limits. Lunar dust, fine as flour and sharp as glass, becomes electrically charged and clings to every surface, wearing down seals, solar panels, and moving parts. Extreme temperature swings stress materials and structures relentlessly, expanding and contracting them without pause. This is why the South Pole, with its regions of near-permanent illumination and comparatively stable temperatures, has become the focal point of virtually every serious colonization plan. Not because it is welcoming, but because it is the least hostile option available. China, however, is not building this future alone. Alongside Russia, a formal partner in the project, a growing list of countries has signed cooperation agreements spanning Asia, the Middle East, Africa, and Latin America. Beijing openly speaks of involving dozens of nations, hundreds of research institutions, and thousands of foreign scientists under a collaboration model described as flexible and multi-layered, where partners can contribute according to their capabilities without being locked into a rigid framework. This vision stands in quiet contrast to the US-led Artemis Accords, which rely on bilateral agreements and a governance structure centered on the United States and its allies. Between these approaches, Europe continues to promote the idea of a moon village, an open, modular ecosystem, almost a city without a single mayor, where public and private actors coexist within a shared infrastructure. These differences are not merely political. They reflect fundamentally different ideas of what it means to inhabit another world. The Chinese project aims to anchor itself physically into the lunar surface, building, covering, excavating, and turning regolith into architecture. The American program has long viewed lunar orbit as the logistical hub, with the gateway station acting as an intermediary between Earth and the surface. Europe, for its part, tends to see the moon primarily as a shared laboratory rather than a territory to be claimed. three visions that currently compete, but that may eventually be forced to converge. There is also a deeper layer, less visible in official statements, but crucial to understanding why the moon has suddenly returned to the center of so many strategies: its role as a cosmic archive. Unlike Earth, the lunar surface is not reshaped by plate tectonics, erosion, rain, or vegetation. Every crater, every basalt flow, every grain of dust preserves a record that stretches back billions of years. Systematic study of the South Pole and the far side means reconstructing the early history of the solar system, the primordial bombardment that shaped the inner planets, and perhaps gaining clearer insight into how water and organic molecules reached Earth in the first place. In this sense, a lunar base is not just a human outpost, but an unprecedented scientific instrument, a geological and astronomical observatory installed on a body that has preserved memories erased everywhere else. The far side in particular offers unique conditions for radio astronomy. Naturally shielded from the electromagnetic interference generated by Earth, it is one of the few places in the inner solar system where it may be possible to observe the universe at very long wavelengths, those that carry information from the era before the first stars formed. It is no coincidence that long-term plans for the International Lunar Research Station include radio telescopes spread across kilometers, miles of surface, lightweight antennas laid out on the regolith like vast cosmic fishing nets. This is astronomy that simply cannot be done from Earth, drowned out by the noise of our own technological civilization. Finally, there is a human, almost psychological dimension that rarely appears in technical documents, but weighs heavily on the long term. Living on the moon means experiencing a radically different existence. Days and nights lasting weeks, a black sky even at local noon, Earth hanging motionless on the horizon like a blue beacon. It means adapting body and mind to a gravity 6 times weaker than Earth's, redefining concepts such as distance, isolation, and community. The first bases will be small artificial worlds, fragile and only seemingly self-sufficient. But precisely because of that, they will become laboratories not of just technology, but of society itself, testing how humanity can organize beyond its home planet. And this is where the Chinese lunar project, beyond rivalries, becomes an experiment that concerns everyone. If it succeeds, it will show that a civilization can extend its presence beyond Earth in a continuous, non-episodic way, turning space exploration from an exceptional adventure into permanent infrastructure. If it fails, it will remind us how difficult it is to truly break the bond with the planet that gave us birth. Either way, the moon stops being a purely symbolic destination and returns to what it has always been, a threshold. The closest and most accessible one, but not the least demanding. And as instruments, modules, experiments, and perhaps soon human footprints destined to last for millions of years begin to accumulate on its gray surface, it becomes increasingly clear that the real leap is not technological, but conceptual. It is no longer about reaching the moon, but about staying there, and about understanding what it means for a species born under a blue sky to learn to call home a world with no air, no liquid water, and no life, at least for now. Okay guys, what do you think? Did watching this video raise any doubts or questions? Let us know in the comments. And if you want to learn more, check out our other videos dedicated to the space race and the problems that are slowing down the return to the moon.